Assalamualaikum warahmatullahi wabarakatuh. To our lecturer, Sir Muhammad Syarif Muhammad Zam. Today, I, Muhammad Syamim Sufyan, and my partner, Muhammad Amrun, will present about our assignment topic, Metabolic Interrelationship.
Hi, my name is Muhammad Amrun. We are from Diploma in Microbiology, Part 3, AS1143A1. Now, I'm going to introduce our member's name. Our first member's name is Muhammad Syamim Sufyan bin Matlazim with matric ID number 2019313431. Our second member's name is Muhammad Amrun bin Jamaluddin with matric ID number 2019396309.
So, I will go to our introduction. Our introduction more to fun fact. Fun fact 1. Eating late at night slow metabolism. There is little evidence to support the fact that eating after 8 p.m. causes weight gain. However, you may be more likely to snack mindlessly in the evening while watching television. So, eat regular meals and snacks throughout the day to prevent extreme swing in the hunger and fullness. If you are eating later in the evening, do so mindfully and put away the snack when you are satisfied. Fun fact 2. Our metabolic rates can change. It's true that genetics help determine our metabolic rates. We can boost metabolism by increasing lean muscle mass. Muscle is metabolically active, which means that people with lean, muscular bodies need more energy to function than people with a higher percentage of body fat. Our muscle mass decreases as we age, and this contributes to a slower metabolic rate. But you can counteract this process by picking up the weight to help lessen this decline.
Our second application of metabolic interrelationship is artificial dialyzer. Artificial dialyzer is a procedure where a dialysis machine and a special filter called dialyzer are used to clean your blood. The kidneys excrete unnecessary metabolic products generated by cell activity from the blood as urine. In the absence of a functioning kidney, artificial dialysis is used to condition the electrolyte concentration and the circulating blood volume and excrete uremic toxin. Artificial dialysis is performed by a dialyzer which bundles approximately 10,000 hollow fibers of approximately 0.2 mm in diameter. Owing to the restriction of dialysis therapy, a complete implantable artificial kidney is desired. However, it has not yet been realized. Blood purification has also been applied to diseases other than renal failure and has come to the called apheresis therapy.
Now we go to the application of metabolic interrelationship. The first application is pleasure-seeking product. First point is clinically demonstrate to help a person to lose weight because the polydextrose attracts water and swell, taking out more space in your stomach. Second point is feel less hunger because it gives you more control to help form healthy eating habits. Point 3. Improve digestive system, and it's resistant to digestive enzyme and leaves the stomach slowly and feel full longer.
Now, we go to biological functions of metabolic interrelationship. Our first biological functions of metabolic interrelationship is skeletal muscle in starvation. A. Carbohydrate metabolism. Low insulin will cause decreased uptake of glucose by skeletal muscles. Thus, glucose metabolism is decreased. B. Lipid metabolism. During the first 2 weeks of starvation, muscles uses of fatty acids from adipose tissue and ketone bodies as fuel. After 3 weeks, muscles decrease utilization of ketone bodies and use only fatty acid. That will cause increases circulating ketone bodies. C. Protein metabolism. During the first few days of starvation, rapid degradation of muscle protein providing AA for gluconeogenesis. After several weeks of starvation, the rate of muscle protein degradation decreased. Then, a decline in need for glucose as a fuel for brain. Our second biological functions of metabolic interrelationship is connection of proteins to glucose metabolism. Proteins are hydrolyzed by a variety of enzymes in cells. Most of the time, the amino acids are recycled into the synthesis of new proteins if there are excess amino acids. However, or if the body is in a state of starvation. Some amino acids will be shunned into the pathways of glucose catabolism. It is important to note that each amino acid must have its amino group removed prior to entry into these pathways. The amino group is converted to ammonia. In mammals, the liver synthesizes urea from the two ammonia molecules and a carbon dioxide molecule. Thus, urea is the principal waste product in mammals, produced from the nitrogen originating in amino acids, and it leaves the body in urine. It should be noted that amino acids can be synthesized from the intermediates and reactants in the cellular respiration cycle.